If your job at a healthcare facility includes disinfecting against viruses, you know prevention is the best medicine, and maintaining healthy spaces starts with a healthy cleaning routine. Grainger's world-class supply chain helps ensure you have the quality products you need when you need them, from disinfectants and cleaning supplies to personal protective equipment, so you can help deliver a clean bill of health. Call 1-800-GRAINGER, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
For the ones who get it done, the most important part is the one you need now. And the best partner is the one who can deliver. That's why millions of maintenance and repair pros trust Grainger. Because we have professional-grade supplies for every industry, even hard-to-find products. And we have same-day pickup and next-day delivery on most orders. But most importantly, we have an unwavering commitment to help keep you up and running. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
This is SpaceTime Series 28, Episode 34, for broadcast on the 19th of March 2025. Coming up on SpaceTime, could supernovae have triggered at least 2 of Earth's mass extinction events? NASA launches its latest stellar mapping mission to study the galaxy. And astronomers discover 128 new moons orbiting the ringed world of Saturn. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
A new study suggests that nearby exploding stars known as supernovae may have been violent enough and close enough to have triggered at least 2 of Earth's known mass extinction events. Supernovae occur when massive stars reach the end of their lives, run out of fuel, and then collapse under the pressure of their own immense gravity. There have been 5 mass extinction events on planet Earth, with a 6th currently underway. The previous 5 include the Endovisian, 444 million years ago, which wiped out between 60 and 86% of all life on Earth. It was thought to have been caused by intense glacial and interglacial periods, creating large sea level swings which dramatically moved shorelines. The tectonic uplift of the Appalachian Mountains during this period created extreme weathering, sequestration of CO2, resulting in changes in climate and ocean chemistry. Then there's the late Devonian mass extinction event 360 million years ago. It's thought to have killed about 70% of all life on Earth. Until now, it was suspected to have been caused by the rapid growth and diversification of land plants, which triggered severe global warming. The biggest was the end Permian mass extinction event 250 million years ago. It was the most devastating, wiping out 96% of all life on Earth. It's been put down to intense volcanic activity in Siberia, resulting in the Siberian traps. They caused global warming, and elevated carbon dioxide and sulfur levels from these volcanoes then caused massive ocean acidification, as well as acid rain and other changes to ocean and land chemistry. Next came the end Triassic mass extinction event 200 million years ago. It killed off about 80% of all life on Earth, and is thought to have been caused by massive underwater volcanic activity in the Central Atlantic Magmatic Province, resulting in global warming and a dramatic change in the chemical composition of the oceans. Of course, the one most people know about is the end Cretaceous mass extinction event 66 million years ago, also known as the KT boundary event. It wiped out 76% of all life on Earth, including all the non-avian dinosaurs. It was caused by the impact of a 10-kilometre wide asteroid slamming into what is now Mexico's Yucatan Peninsula. That triggered a global cataclysm with intense volcanic activity, tectonic uplift and rapid impact winter cooling from ejected debris and from the global fires they started. And finally, we have the Anthropocene or Holocene mass extinction event, which we're currently going through at the moment. It's been caused by human activity. Studies show current extinction rates are up to 1,000 times higher than natural background rates, and they're accelerating. Now, scientists are suggesting that both the Devonian and Ordovician mass extinction events may actually have been caused by supernovae. These stellar explosions are caused by the deaths of massive stars. In this case, stars close enough and powerful enough to strip the Earth's atmosphere of its ozone, triggering acid rain and exposing life to harmful ultraviolet radiation from the sun. The new study, reported in the monthly notices of the Royal Astronomical Society, found that the rate of supernovae occurring near our planet is consistent with the timings of both mass extinctions. The authors claim it's a great illustration of how massive stars can act both as creators and destructors of life. That's because supernovae are also known to spread the heavy elements that help form and support life across the universe. Well, at least here on Earth, as that's the only life we know of for sure. The study's lead author, Alexis Quintana from Keele University, says supernovae bring heavy elements into the interstellar medium, which can then be used to form new stars and planets. However, if a planet, including the Earth, is located too close to one of these events, it can have devastating effects. Quintana and colleagues reached their findings after carrying out a census of massive stars within a kiloparsec of the Sun. That's around 3,260 light-years. They were studying the distribution of these massive stars, known as OB blue stars, in order to learn more about how star clusters and galaxies form and the rates at which these stars form in our galaxy. OB blue stars are sort of like the James Dean of the stellar world. They're very bright, live fast and die young. So it's a way of knowing just how often these OB blue stars are formed. The census allowed the authors to calculate the rate at which supernovae occur within the galaxy, and that's important both for the observations of supernovae and the production of supernova remnants, as well as massive stellar remnants such as black holes and neutron stars. The data will also help develop the next generation of gravitational wave detectors. Quintana and colleagues calculated the supernova rate within 20 parsecs of the Sun, approximately 65 light-years, and then compared this with the approximate rate of mass extinction events on Earth. They then excluded extinction events linked to other known factors, such as the asteroid impact 66 million years ago, as well as massive tectonic upheavals and ice ages. Now, comparing these data sets, the authors found their research best fitted the idea that a supernova explosion could have been responsible for both the late Devonian and late Ordovician extinction events. They found that the calculated rate of nearby supernovae was consistent with the rate of mass extinction events. Astronomers believe around 1 or 2 supernovae explode within the Milky Way galaxy every century. At the moment, there are just 2 nearby stars, at least that we know of, which are likely to go supernovae in the near future. Now, astronomically speaking, that means it could be tomorrow or it could be in 1 million years' time. Those 2 stars are Antares and Betelgeuse. But the good news is both are more than 500 light-years away. This is SpaceTime. Still to come, NASA launches its latest stellar mapping mission to study the galaxy, and astronomers discover 128 new moons orbiting the ring world of Saturn. That brings Saturn's total count of moons to 274. All that and more still to come on SpaceTime. NASA has successfully launched its new SPHEREx stellar mapping mission. SPHEREx stands for Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICE's Explorer spacecraft. No wonder they call it SPHEREx. The orbiting observatory will map the entire celestial sky 4 times over a 2-year period, in the process creating a detailed 3-dimensional map of over 450 million galaxies. SPHEREx works by detecting infrared light emitted from warm objects, including stars and galaxies. Using a technique called spectroscopy, SPHEREx will separate the infrared light emitted by hundreds of millions of stars and galaxies into 102 individual colour bands, in the same way a prism will split sunlight into a rainbow. Observing these spectra separately will allow scientists to reveal various properties of the objects emitting that light, and the material the light's passing through to reach the spectrograph. And this includes the composition and, in the case of galaxies, their distance from the Earth. No other all-sky survey will have performed spectroscopy in so many wavelengths or on so many sources. The mission's all-sky spectroscopic map can then be used for a wide variety of scientific investigations, including looking at the mystery of cosmic inflation. That's the phenomenon which caused the universe to suddenly expand a trillion-fold in the first fraction of a second after the Big Bang 13.8 billion years ago. See, it's only by such cosmic expansion that we can explain why the universe looks the same in all directions. So this nearly instantaneous event left an impression on the large-scale distribution of matter right across the universe. The mission will map the distribution of more than 450 million galaxies, thereby improving astronomers' understanding of the physics behind cosmic inflation. SPHEREx will also measure the total glow of all galaxies, including ones that other telescopes can't easily detect. When combined with studies of individual galaxies by other telescopes, the measurements of this overall glow will allow a more complete picture of how the light output of galaxies has changed over the history of the universe. At the same time, the spectroscopy will allow SPHEREx to seek out frozen water, carbon dioxide and other key ingredients for life. The mission will provide an unprecedented survey of the location and abundance of these icy compounds across the Milky Way galaxy, thereby giving astronomers a better insight into the interstellar chemistry which set the stage for life to develop. This report from NASA TV.
SPHEREx is NASA's latest Explorer mission in astrophysics. It's a small telescope, but it has this unique and powerful capability of doing spectroscopy everywhere.
We are going to survey the entire celestial sphere and collect a data set that will help us answer 3 fundamental science questions.
It's going to tell us about the origin of the universe, the birth and formation history of galaxies, and the abundance of essential molecules such as water in the early stages of star and planet formation.
The great thing about SPHEREx is not only will we view the entire sky 4 times, but we will see it in nearly 100 near-infrared colors. And that's really never been done before.
According to our current understanding of the universe, we think that in the very earliest times, and I'm talking here a fraction of a second, much less than a nanosecond, the universe appeared to have gone through an accelerating expansion called inflation. And this is really a profound idea, and we're very interested to test it. And so one way to do this is to look at how matter is distributed over the universe. We want to map hundreds of millions of galaxies in 3 dimensions. What SPHEREx does, in addition to mapping out all these galaxies, is we cover the whole sky. So we can measure these galaxies over the largest part of the range we can see, which is the entire sky. And we want to cover the full range of distances from today to as far back as we can see.
We know there are about 100 billion galaxies in the universe, maybe more, but we still don't have a good understanding how these galaxies came to be. Did they all form at the same time? Did they change in size and luminosity or brightness over time? So the intent with SPHEREx is for us to figure out the formation history of galaxies, where do they exactly form, and how do they grow over cosmic time. And that information is crucial for us because that'll allow us to separate various theories we have right now on the formation and growth of galaxies.
Every day, we all pick up a bottle of water and we drink it without thinking. But to scientists, we still don't understand how this water arrived at Earth. Where was it formed? How did it get here? And this is an area in which SPHEREx will make major strides. Water molecules bounce around in interstellar space, and every once in a while, they will impact a small dust grain. When a water molecule collides with one of these dust grains, it freezes on the surface. It doesn't leave the surface. And these ice-covered dust grains participate in the collapse to form regions where new planets are formed. SPHEREx, for the first time, will allow us to directly measure not just the location of these key ingredients, but the abundances of these key ingredients.
We expect to have spectra of order 500 million galaxies, hundreds of millions of stars.
We will really see anything that is observable in near-infrared, and that's a lot of things.
And so we can expect some exciting and unusual discoveries that come from this.
And in that report from NASA TV, we heard from SPHEREx Principal Investigator Jamie Bock from NASA's JPL Caltech, SPHEREx Deputy Project Manager Beth Fabinski, also from NASA JPL, SPHEREx Galaxy Formation Lead Asantha Khoury from the University of California, Irvine, and SPHEREx Interstellar ICES Lead Gary Melnick from the Harvard-Smithsonian Center for Astrophysics. Meanwhile, sharing the SPHEREx ride aboard the SpaceX Falcon 9 rocket from Launch Complex 4 East at the Vandenberg Space Force Base in California was NASA's PUNCH mission. Punch, the polarimeter to unify the corona and heliosphere, is a constellation of 4 small suitcase-sized spacecraft designed to map the region where the Sun's outer atmosphere, the corona, transitions to the solar wind. That's the constant stream of charged particles flowing out from the Sun. Both SPHEREx and Punch are flying in Sun-synchronous low-Earth orbits, where their positions relative to the Sun remains the same throughout the year. Each 98-minute orbit will allow SPHEREx to view a 360-degree strip of the celestial sky. Now, as Earth orbits around the Sun, that strip slowly advances, enabling SPHEREx to image almost the entire sky every 6 months. Now, as for the Punch mission, well, its orbit provides a clear view in all directions around the Sun during its 2-year primary mission. Punch principal investigator Craig DeForest from the Southwest Research Institute in San Antonio, Texas, says that to get the data he needs, scientists really needed to create an instrument as large as the Earth itself. But because that's impossible, instead they developed 4 small suitcase-sized spacecraft synchronized to orbit around the entire planet, creating a virtual instrument 13,000 kilometers across. And that lets astronomers look up to 45 degrees from the Sun in all directions all the time. One satellite carries a chronograph, the narrow-field imager that watches the Sun's corona continuously, and the other 3 carry wide-field imagers designed to view the very faint outermost portion of the solar corona as well as the solar winds. Punch will also track space weather events such as solar flares and coronal mass ejections as they travel across the solar system, and it will be the first to be able to do it in 3 dimensions. Each spacecraft includes a camera capable of collecting 3 raw images through 3 different polarizing filters every 4 minutes. And these will then be combined to produce a clear unpolarized image every 8 minutes for calibration. The images allow scientists to discern the exact trajectory and speed of coronal mass ejections as they move through the inner solar system, thereby improving on current instruments that only measure the corona itself and don't routinely exploit the polarization of light. This report from NASA TV.
PUNCH is an acronym. It stands for polarimeter to unify the corona and heliosphere.
The corona is the outer atmosphere of the Sun. It's the part that is no longer gravitationally bound to the Sun, and it has so much energy that it flows outwards, filling our solar system, and pushes against the interstellar medium, making a bubble, and that is the heliosphere. And this system of how the corona turns into the heliosphere is what PUNCH is trying to study.
So PUNCH is fundamentally 4 cameras that work together to make composite movies. We have a narrow field imager that views the space close to the Sun, and then we have 3 separate wide field imagers, each of which has a large squarish field of view that looks way off to the side, out to 45 degrees away from the Sun. That allows us to do something that no other mission has been able to do, which is routinely track coronal mass ejections, space storms, all the way across the solar system as they approach the Earth.
By better understanding these storms and better understanding how they propagate on their way to the Earth, we'll be able to inform our partners on how to better forecast these events in the future. And that's really important for protecting our astronauts, our satellites, and our power grids.
Once we start producing images, you'll be able to look at PUNCH data directly and see the kind of science we're engaged in. You'll be able to see things that are present in the sky right now, and you're not aware of them because they're washed out by the brightness of the sky itself.
We are poised to do tremendous science with PUNCH because it provides this global context of what is happening in the corona and what is happening throughout the inner solar system so that we can connect the details to the bigger picture.
You might say that PUNCH is the next chapter in the study of heliophysics as we bring imaging and cross-scale understanding out so that we can develop a coherent understanding of the entire system that starts at the corona and extends out to envelop the planets themselves.
And in that report from NASA TV, we heard from PUNCH mission scientist Nicolene Viol from NASA's Goddard Space Flight Center in Greenbelt, Maryland, and PUNCH principal investigator Craig DeForest from the Southwest Research Institute in San Antonio, Texas. This is SpaceTime. Still to come, 128 new moons discovered orbiting Saturn. And later in the science report, a new study warns that by the year 2030, the average Australian diet will include far less fruit and a lot more junk food. All that and more still to come on SpaceTime. Astronomers have just found an additional 128 moons orbiting the ringed world of Saturn. The new discoveries bring the Saturnian system's total confirmed count of moons to 274, and that compares to Jupiter, which has 95, at least that we know of. Astronomers from Taiwan, Canada, the United States and France made the discovery using the Canada-France-Hawaii telescope back in 2023. However, the new finds weren't officially recognised by the International Astronomical Union, the official governing body, until now. The discovery's been reported on the pre-press physics website archive.org, and it's been submitted for publication in the Planetary Science Journal. Saturn's moons range in size from the giant moon Titan, which is larger than the planet Mercury, right down to small frozen space rocks the size of a football field. These new discoveries are all tiny potato-shaped moonlets, each just a few kilometres wide, and they're within a range of orbits within the so-called Norse group. Now, these are moons that orbit in a retrograde direction, that is, orbiting opposite to the direction of the planet's spin, and they're on inclined angles on highly elliptical paths, all well beyond Saturn's rings. The authors think they're all likely to be fragments of a number of smaller captured moons caught by Saturn's gravity early in the solar system's history. These moons were later broken apart through violent collisions, either with other Saturnian moons or with passing comets. This is SpaceTime. And time now for another quick look at some of the other stories making news in science this week with a science report. A new study suggests that both starting and quitting drinking booze has effects on cholesterol levels. A report in the Journal of the American Medical Association looked at 58,000 people going for their annual health checkups, finding that those who had stopped drinking alcohol wound up having higher levels of low-density lipoproteins, that's the bad cholesterol, and lower levels of high-density lipoprotein, the good cholesterol, compared to people who had continued to drink. And the authors also found the opposite when people started drinking, with these cholesterol level changes being more pronounced at higher levels of consumption. While this kind of study can't directly prove that alcohol was a key factor in these changes, it does suggest that alcohol drinking habits should be investigated when managing someone's cholesterol levels. A new study has found that crocodiles in Australia's top end are eating 9 times more now than what they did back in the 1970s. A report in the journal The Proceedings of the Royal Society B suggests that crocs are dining on increasing numbers of feral pigs and water buffalo roaming the region, which spans the northern parts of Western Australia, Queensland and the Northern Territory. This means that the predators are helping to keep the pest population under control. The authors looked at the food intake of crocodiles across northern Australia over a 50-year period, during which time the population increased from just a few thousand to well over 100,000 today. They found that the crocodile population's annual prey consumption increased ninefold between 1979 and 2019, and they shifted from eating aquatic prey to eating more land animals. The authors say this suggests that crocodiles could be helping to put pressure on invasive feral animals such as pigs and Asian water buffaloes. A new study warns that by the year 2030, and remember that's just 5 years away, the Australian diet will include a lot less fruit and way more junk food. A report in the Australian and New Zealand Journal of Public Health looked at the diets of more than 275,000 Australian adults over a 9-year period, tracking current diets and predicting future trends. The participants were asked to report their usual intake of core foods such as fruits, vegetables, grains, meats and dairy, as well as any meat and dairy alternatives, and junk foods such as cakes, cookies, candies, confectionery, takeaways, savoury pies and pasties, sugar-sweetened beverages and alcohol. Based on the survey's trends, the authors then predicted what the Australian diet may look like in 2030. They say that by then, fruit intake is expected to decrease by 9.7%, and discretionary food intake, in other words junk food, will increase by an incredible 18.3%. The only good news is that vegetable intake is expected to remain fairly stable, although that's already well short of national targets. It's been a busy week in technology news. Palestinian terrorists working through servers in the Ukraine have launched a cyber attack on the social media network X, formerly known as Twitter, and warnings have been issued about an update to some Google Pixel phones that can cause their batteries to explode. With the details of these stories and more, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The X outage, I noticed that pages weren't loading. X is slow to react when you push the like button. It's claimed that these attacks came via the Ukraine. Palestinians using VPNs to appear as though they're coming via the Ukraine. Now, of course, with Ukraine, it wouldn't make sense for them to want to upset Elon or Trump, seeing as they're trying to get a good deal out of the US. But the reality is that the network was taken down, and I found that I had to use a VPN connected through to the US to be able to get service. It lasted a couple of hours. It sort of seemed to come and go and come and go. The next day, there seemed to be some sort of residual slowness. Yeah.
The other big issue was Google.
Yeah, look, there was a problem with the Pixel 4 or 4a battery, and this is already an older phone. I mean, it was sold 3 or 4 years ago, and there was an update that was meant to fix the battery life issue, but people were noticing that the battery was dying very quickly and was overheating, and it's now been recalled. I mean, it's very rare for that sort of thing to happen. The last time we saw that was with the Galaxy Note 7. Batteries are also in the spotlight because, of course, Australia had the big now ex-cyclone Alfred, which was predicted to cause all sorts of chaos and mayhem.
Well,
and
300,000 homes were blacked out as a result.
Yeah, they were. And, of course, if you are without power for several days, I mean, what do you do? Well, on your phone, most of them have a battery saving mode. Now, on a Samsung Galaxy S25 Ultra, I would notice that with about 93%, I would have 3.5 or 4 days worth of power if I did nothing with the phone. And if I put power saving mode on, I would have closer to 6 days, over 5 days and several hours worth of power, again, if I did nothing with the phone. But it achieved that by putting the screen refresh rate down to 60 hertz. It would cut the CPU speed down to 70%. It would turn various things off, and this could definitely extend your lifespan. But also, on modern phones, you are able to set your maximum charge to 80%, 80, 85, 90, 95, 100. And people say don't charge your phone more than 80%. And once it hits 20%, start to charge it. And this is done to stop the battery from wearing out faster. With the old nickel-cadmium batteries, there was a memory effect if you charged it before it was fully discharged, and if you charged it to full, but you were charging it, say, at 80% because you wanted to give it a charge. Eventually, you would have a battery effect, memory effect, where it would remember and would lose capacity. Modern smartphones don't work in the same way as such, but they can lose their life. And we all know that after a couple of years, 2 or 3 years, our phones are no longer holding as much charge as they once did.
And one other big issue was a new update for Apple.
So there's updates for the iPad, the iPhone, and the Mac, and these were designed to close down a very sophisticated attack on the sandbox for the Safari web browser. So normally when code is run from the internet via a web page, it stays within a protected space that cannot get out to the rest of the operating system. And in this case, hackers figured out how to do that. And that was for very targeted attacks against, effectively, freedom fighters, people who are against certain governments and communicating on phones they think are secure, and yet the hackers find some sort of way in. Now, this sort of attack has been done in the past, and there is no effective antivirus that you can really get for Apple's iPhones and iPads. You can buy antivirus for Macs, but Apple itself is the security provider. So they issue a security update, and there are no major features this time, but the one feature is that it closes the security hole. But the other big thing with Apple News is that there should be an entire redesign for iOS 19, which we'll see at the Worldwide Developer Conference this year. Apple has delayed some of its Apple Intelligence or artificial intelligence features till iOS 19, perhaps even iOS 20. They're going to have to redesign Siri from scratch, because if you have a large language model that acts upon private information inside of apps and then does actions on your behalf, these large language models can be attacked and they can be hacked. And so Apple has to really redesign it to be able to fully say its systems are as private as Apple claims. So expect big changes for the iPhone operating system, the iPad operating system. Don't know if the Mac will change it as well, but it'll be based upon the Vision OS with round circular icons and other translucent menus and this whole look and feel that will be something that will be a sight to behold. Expect it to see it from the middle of this year.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.